Welcome to lecture 3.3. Today in class we recognized a pattern that was really useful for taking the derivative of a polynomial function, and we summarized that pattern into 4 rules. Well, tonight's video is going to be about taking those 4 rules and applying them to slightly more advanced situations. It's going to test whether you really understood what happened today in class and whether you really trust it. Later on this week, we're going to talk about a couple other rules, including the product, quotient, and chain rule. And ultimately, all week, what we're doing is we're just finding derivative functions. Don't forget the stuff from last week where you had a meaning behind it, but this is going to be more computational, more algebraic. To start off, you should recognize the 4 rules at the top of the screen. I have them written here just in the algebraic form, but you should be able to say out loud the meaning behind each of these. They should be memorized, and we're going to use them a whole bunch. Here's where we start. So I've got 2 examples here, and our goal is going to be to find the derivative of these 2 functions. At initial glance, it might look like these are derivatives that we don't know how to calculate yet. But for each of these examples, there's going to be a sneaky way to rewrite the problem that allows you to use one of the 4 rules up at the top. Let's take a look. The instructions for each example is to find the derivative function. Example A is a reciprocal function. So this is not like the examples from class, which were all polynomials. But if you remember from Algebra 2, there is a way to rewrite this reciprocal function so that it becomes a power function. And that would be to rewrite f of x, instead of being 1 over x, to write it as x to the negative 1 power. Of course, I can do that because the meaning of a negative exponent is just a reciprocal of what you started with. Now that it's in this format, taking the derivative is easy. All I need to do is multiply the exponent in front and subtract 1 from the exponent that I started with. This gives me a derivative of negative 1x to the negative 2. That's the correct derivative, but normally we would want to write it in a slightly nicer fashion. If you think about it, x to the negative 2 power is just 1 over x squared. So for my final answer, I move the x squared to the bottom. And in this case, it's going to be a negative 1 over x squared because of the negative coefficient. That's your derivative, and that would be the answer. Notice the sneaky step I took was to rewrite the fraction, or the reciprocal, using a negative exponent. We can do the same thing on the second one. We would just change the x squared on the bottom to a x to the negative 2 power. Then we follow the derivative rules, multiply the exponent, and subtract 1, which gives us a derivative of negative 6x to the negative 3. But the best way to write that final answer would be as negative 6 over x cubed. Follow my examples and do the 3 for you. When you press play, I'll show you my work. Here's the work for numbers 1 and 2. In each case, my first step was to rewrite the original function using a negative exponent, and then I just followed the exponent rules, the power rule from above. 3, the answer was negative 5 over 2x to the 6th. Be a little careful with these fractions. Notice how when I have a fraction out front, I end up joining the negative exponent term with the bottom of the fraction. Great, should be simple enough. Let's look at another example where we can use an Algebra 2 trick. We can also rewrite square root functions using a particular exponent. The simplest example is just the square root function, which is the same thing as the 1 over 2 exponent. If it helps you, remember that a square root secretly has a 2 out front here, and maybe that'll help you think about these exponents. Once I have it written as a power function, I'm just going to follow the power rule again. Be careful with your fractions, which are going to turn into coefficients. Just like before, I multiply the exponent in front, and then I subtract 1 from the exponent that I had. Now this becomes slightly trickier to simplify because you have to get a common denominator up here in order to simplify the exponent. I would imagine that some of you can go ahead and just subtract 1/2 minus 1 and get negative 1/2, but if you want to see the middle step for future reference, I would have rewritten 1 as 2 over 2, and then you subtract the numerator and keep the denominator. In any case, your derivative is going to be 1/2 x to the negative 1/2, but we don't really want to leave our answer like that. Remember, a negative exponent is going to flip this x and make some sort of reciprocal, and then a 1/2 really means a square root. So ultimately, your derivative would look like this. When I moved the x to the bottom, the exponent went from negative to positive, and then I reinterpreted the fraction exponent into the square root that it is. Let's try b. As usual, the first step is going to be to rewrite this function using an exponent. In this case, a cube root is the same thing as a 1/3 power. Now, notice that I used parentheses, and I have to use parentheses because 8x squared, the entire term, is inside this radical. C is going to be different, so watch out for that difference. Now, right away, I can't use the power rule yet because I have a coefficient inside. So I actually need to distribute this exponent to both. And I'm going to remind you that a 1/3 is the same thing as a cube root, and you should know what the cube root of 8 is. It's 2. So this expression is the same thing as 2 times x to the 2/3. And the rule for exponents when you have parentheses is you just multiply them. So 2 times 1/3 is where the 2 over 3 came from. Now that I've rewritten my original function, I'm ready to take the derivative. I multiply the exponent in front as a coefficient. Make sure you keep the original coefficient, which I was missing a second ago. And then, of course, we subtract 1 from the exponent. Next step is to simplify. 2 times 2 over 3 is 4 over 3. Leave it as a fraction, don't use decimals. And 2/3 minus 1 is negative 1/3. Since this is a negative fraction, I'm going to expect to have a radical on the bottom of my final answer, which would be 4 over 3 cube root of x. Take a moment to make sure that you know where this cube root of x came from and why it's on the bottom. Let's try the last one here. Can you think how I'm going to have to rewrite this expression? Right, so in this case, since the coefficient is outside of the radical symbol, we don't have to take the cube root of 8. It just sits out front and becomes a coefficient. The power here is 2 over 3. 2 on the inside goes on the top. The index of the radical becomes the denominator of your exponent, which is a fraction. And now we're going to follow the normal derivative rules. Multiply the exponent and subtract 1, which gives me 16/3 x to the negative 1/3 power. Just like before, the negative 1/3 power is going to turn into a cube root on the bottom. It'll be 16 over 3 times the cube root of x. Follow my examples, be very careful with your coefficients and your exponents, and do the 2 that are for you. Great, here's the work for number 1. And here's the work for number 2. Before I move on for a second, I just want to make sure that you have the meaning of what's going on in the back of your mind. We're going to spend a whole week doing a bunch of algebra, but there is a context here that you should remember from last week. We're starting with a particular function. We're finding another function, which is called the derivative function, and the outputs of this function tell you the slope of the original. So for example, I could pick any number I want, x equals 1, and I could plug 1 in for the derivative function, and the number I would get would tell me the slope of the original function at x equals 1. And when we say slope, we mean the slope of a tangent line, of course. Okay, let's do some examples that put these rules together. And the goal is for you to be really creative. The algebra may look frustrating, but if you really understand what's going on, you should be able to look at these and get an idea for how you're going to solve them almost immediately. Just like before, the trick to taking the derivative of each of these functions is going to be to try and rewrite it so that we can use one of those 4 simple rules from class today. Here's what I would try for the first one. Just using some really basic algebra rules, I know that these 2 expressions equal each other. I just split this one into 2 fractions. If I subtracted these from each other, I would get this expression right back. Now the good news about this is that I can now simplify the expression that I have to be x cubed minus 2x to the negative 1. And again, notice the negative 1 just comes from subtracting 1 minus 2. Well, these are power functions. There's two terms, but you should remember from class that two terms are fine. We just take the derivative of each one separately. So now I can take the derivative simply by multiplying each exponent and subtracting 1. And it's worth being a little bit careful with the signs of the second term. I prefer to just put a plus always, and then I keep the -2 negative, and I multiply the -1 using parentheses. Either way, your answer will turn out positive. So you could just look at this and say, oh, -2 times -1 is +2, or you could write it out as I have. Ultimately, the derivative of the first term is 3x squared, and the derivative of the second term is 2x to the -2, but the best way to write that would really actually be 2 over x squared. There's your derivative function. Let's try b. Just like before, my goal is going to be to rewrite this using some power functions. So I'll split it in two fractions. And this may not immediately look helpful because we can't simplify it, but you might remember one other thing that's going to be the key to this problem, which is that a square root is really just a 1/2 power. So technically what I have is 5x squared divided by x to the 1/2, and 4x also divided by x to the 1/2. Now, when we divide terms, we can just subtract the exponents. That's as long as there's no addition or subtraction on the numerator. We can just simplify that using exponent rules. So actually, f of x equals 5x to the 3 over 2, and 4x to the 1/2. Again, 1/2 came from subtracting 1 minus 1/2, and 3/2 came from subtracting 2 minus 1/2. Okay, this is the original function still. We've just rewritten it. Now I take the derivative. And when I simplify my coefficients and subtract the exponents, we get 15 over 2x to the 1/2 plus 2x to the -1/2. But a 1/2 power is a square root, so the final answer really should be 15 over 2 times the square root of x plus 2 over the square root of x. Again, the negative exponent is why the square root's on the bottom. Let me move my work out of the way here, and you have 3 to try for yourself. Pay attention on the third one. I slipped something in from class there. I want to see if you catch it. Awesome. Here's the work for number 1. I'm going to just move through the answers here, so if you need to look at it for longer, please do press pause. Make sure you know where everything comes from. And number 2. And then number 3. Squeezing it in right here. Notice for this last one that I did not split the fraction up into a product. I actually FOILed out the top, which is where these top terms came from, and then split them up into separate terms, which gave me power functions that were easy to take the derivative of. To conclude this video, I just want to put this in context. So there's a lot of functions now that you could take the derivative of, just using those 4 simple rules that we learned in class. But that really doesn't mean that you can find any derivative. Nor does it mean we're always going to use the rules. So take a look at all the different functions on the screen, and you're going to refer to them on Edpuzzle just by the letter name. So this is the function h, this is the function r. Out of all of these functions, which ones do you know how to take the derivative of as of right now? You don't have to actually calculate it. Just tell me which ones you think you could. Right, so f would be pretty simple. We just split it into 2 pieces. S is probably pretty simple. We'd FOIL it out first, and then no problem. And t, actually, we could do, if you think about it, the square root of x is x to the 1/2 power. And when you multiply bases, you add exponents. So this really is the same thing as x to the 2.5 power, and then that's a power function which we can take the derivative of. But what about the other ones here? Sine squared, tangent, the square root of this long thing. These even look pretty familiar. They just have square roots and squares. They don't even have trig in them. But given the rules that we have right now, we can't find these derivatives. We're going to need some other rules. Now, that's what's coming up in a future video. But you actually could take the derivative. So don't forget that we have some other skills. You could use your calculator to find the derivative, graph it, Or you could use the limit definition. So just because we don't know how to find the derivative doesn't mean it doesn't exist. This is a recurring theme for us in calculus. Great. That's it for tonight. I'll see you in class.